Hi everyone, welcome to another online review session for Math 111. This is our 7th, and we're going to cover 2 quizzes today. Let's see, it's quiz 10 and 11 that we have this week. So as I always do, I go through and just kind of pick out some of the main topics from those quizzes and figure I'll give you a little bit of information on it. As a reminder, you can always send me any questions you want during the week and I will answer those here. I never get any, but if you ever have any, feel free to send them to me and I'll work them out for you. So on quiz 10, there's really 2 main topics. One of them is this idea of function transformation. Pretty tricky topic. It really confuses a lot of people. What I think, well, I have a way that I do them, which is a little bit different than how your book does them. So what I was thinking for this is I'll work through these problems, and I'll kind of do them both ways. I'll describe how your book would do it, but I'm also going to show you another way to do it just because I think it's less confusing, so maybe it'll make life easier for you. So most books will tell you there's 6 different types of function transformations. I prefer to think there's only 4 of them. We have kind of 2 different classes. We have vertical transformations and we got horizontal transformations, meaning some things are going to move us up and down. They're going to affect the y-coordinate. And some things are going to move left to right. They're going to affect the x-coordinate. And so really the 2 types, the way I like to break it up, is what your book refers to as shifts and either stretches or flips. Your book will think about this like 3 different types. I like to think about it as just 2 because really these are the exact same thing. So what I'll do is kind of make this little chart here. And so the thing to know is that there's really 2 different types. There's vertical shifts and vertical, these stretch slash flips. And similarly, there's horizontal. And what happens is everything on the vertical side kind of works out nicely, works out as you would expect it to. And everything horizontal is kind of the opposite of how you would expect it to. And if that makes sense to you, that's great. I'll explain that in a little bit more detail as I go. Anyways, an example of a vertical shift would be something like if you have some sort of function and then you add a number to that function. So example, f of x plus 2. Your book will say that shifts up by 2, which is fine. That's easy enough to do. I prefer to think about it as you're going to add 2 to all y coordinates. I don't necessarily think that this is any simpler than just shift everything up by 2. But I think when we do the rest of these, it'll be easier to think about it this way. So f of x plus 2, for example, you'd add 2 to all the y coordinates. F of x minus 4, you'd subtract 4 from all the y coordinates. Whatever is here is what you add to all the y's. Similarly, if we had a number times f of x, we're going to multiply. And we're going to do all the y coordinates, because everything in this column is y coordinates. We're going to multiply all y's by 3. Your book will tell you that you stretch by a factor of 3. I think that can be really confusing, kind of where you stretch relative to. It can really mess people up. Multiplying all the y's by 3, that's a little bit less ambiguous in my mind. Your book will tell you if there's a negative out in front that you then flip. I don't even consider that. I completely ignore that. If this were negative 3 out here, I just think, all right, multiply all my y coordinates by negative 3. Whatever number's here, whether it's negative or positive, is what I'm multiplying all my y coordinates by. It's that simple. These are all just one thing. For horizontal, and I'm even going to label these. I'm going to put a 1 here and a 2 here. Why? Because if you have both types, you have to do these before you do these. Okay? Horizontal, similar. We have shifts, as your book will refer to them, or stretches slash flips. The thing to know in horizontal is everything is backwards. So things end up happening horizontally if we're affecting the x as opposed to the f of x. Note that I'm adding 2 to f of x here. I'm multiplying f of x by 3 here. Over here, I might have f of x plus 2, for example, if I affect the x value. So I'm changing the x coordinate. It's a horizontal. Since I'm adding, it's a shift. So a horizontal shift. You look at this and you're like, oh, sure, I'd go to the right by 2. You think you would. That would make a lot of sense. You don't. You go to the left by 2. We're actually going to subtract whatever number is there. So subtract 2 from all y coordinates. Sorry, all x coordinates. X is because now I'm talking about horizontal stuff. So if this were f of x minus 3, you'd add 3. So you subtract whatever numbers here. Subtracting negative is the same as adding. Why subtracting instead of adding? The easiest answer is because everything in horizontal is backwards. It could be adding, it's actually subtracting. There's a logic for that, a reason it works out. But trying to explain the logic, I end up confusing a lot of people, so I'm not going to bother, at least not in this review session. Just know that you subtract 2 from all the x coordinates. Similarly, if I had f of 3x, for example, note now I'm multiplying the x by 3, not the f of x. Then what I'm going to do, you'd be like, oh, I got you. It's going to be x's. I'm going to multiply all the x's by 3. Actually, no. You're going to divide all the x's by 3. Why? There's a logic to it. I could break down the logic. It would take a long time. Probably the easier answer is because everything horizontal is backwards. I said before that same idea with negatives. If this were a negative 3x, your book would tell you there's 2 different transformations. There's a stretch or a compression and a flip. I'll tell you there's not. There's just one thing. Just divide all of the x coordinates by negative 3 if this were negative 3 right here. It's 1/2, divide by 1/2. Dividing by a fraction like that, dividing by 1/2 is the same as multiplying by 2. Over here, I lied to you, is what I did over here. Over here, we're going to do these first and these second. Sorry about that. You always do the stretches first and then the shifts second. Why? Because everything vertical makes sense. Of course, you multiply before you add. If you think of order of operations, multiplication comes before addition. This should be 1 and this should be 2. And you're like, okay, then put a 1 and a 2 over here. Actually, since they're horizontal, everything is backwards. Even the order you apply them is backwards. Do these first, these second. You're like, what if you have some horizontal and some vertical? It makes no difference. You can do them in any order you want between horizontal and vertical. Just know that if you have more than one of one type, so if you have 2 different vertical transformations, do these first, these second. If you have 2 different horizontals, do these first, these seconds. If you have 4, if you have all 4 of these types, doesn't matter if you do your verticals first or your horizontals first, but it does matter that of the 2 horizontals, you do this type before this type. And of the 2 verticals, you do this type before this type. All right, that's very abstract. I only wanted to mention all that because I know that's different from your book, and I think it makes it easier to do all of these problems. I'm going to actually do some examples now. So in this first one, it wants to sketch a graph of this function by applying function transformations. So what you have to note here is that this 2 and this negative 1 are both affecting my graph. The f of the function that the base function, the thing that this is starting with, is x squared. Just because I have this squared up here. So kind of the starting spot is this graph of the standard parabola, 2, 3, 4. Looks something like this. This is just x squared right here. What I'm going to now do is apply these transformations, maybe in a different color, by matching them up here. So this one, this 2 right here, is, first of all, is it vertical or horizontal? Well, it's vertical because I'm not changing the x coordinate, I'm changing the f of x, I'm changing the x squared. I'm multiplying x squared by 2. This is not 2x squared. It's x squared times 2. So what I'm doing is I'm multiplying the f of x by 2. It's this type down here. It's a vertical type. I'll say it's vertical 1. It's the ones I do first out of my verticals. Similarly, this negative 1 right here is the second vertical type. It's this one over here. This isn't x minus 1 squared. I'm not affecting the x value. I'm affecting the f of x value, the x squared, subtracting 1 from that. So I have these 2 transformations. The way I think about doing these, a little different than how your book does it, is first, this type says I should multiply all my y coordinates by 2. This y coordinate used to be 0. 0 times 2 is still 2. This y coordinate used to be 1. 1 times 2 is 2. This y coordinate used to be 4. 4 times 2 is 8. 5, 6, 7, 8 goes up here. This y coordinate used to be 1. 1 times 2 is 2. This used to be 4. 4 times 2 is 8. What I get is sort of this graph that's dotted in red. That's not the final answer. That's only applying this first transformation. I now want to apply this second transformation. This one says subtract 1 from all of those y's. This y in red right here, maybe I'll switch, no, I'll stay with the same color. Is it 0? 0 minus 1? Negative 1. This guy goes here. This guy that started at 1 went up to 2. 2 minus 1 to shift it down 1 brings it back to here, back where it started. This 4 went up to 8, but 8 minus 1 is 7, so it's going to end up right in there. Similarly, this 1 went up to 2, then back down to 1. This 4 goes up to 8, and then back down to 7. What I get for my final answer is this graph going through all of these dots. Something like that. So if you can see that thing in red, that's the final answer. I didn't say the word, I didn't stretch, I didn't shift, I didn't use those words. Instead, I just added and multiplied numbers by the coordinates. I think it's easier to do it that way. You should feel free to do it however you want, whatever works best for you. All right, let's do a couple more examples just so I can illustrate these. This right here is a horizontal transformation. Also, this is. Why? Because I'm changing the x-coordinate, not the f of x. I'm doing things inside these parentheses here. So I have two different types. When you multiply by the x, you get this second horizontal type. And when you add or subtract something to the x, you get this first horizontal type. So what that means is if I start out with that same graph, I'll make it a little bigger. Pick a few reference points, 1, 2, 3, 4. You don't have to do all 5 of these reference points. You can just keep a couple of them and then kind of draw the line connecting them. But I like to start out with all 5, just so I get a really good idea of the shape of the final answer. And then apply your transformations. So let's see. This first one, I have this minus 2. You'd think that would be subtract 2 from all of the x-coordinates, because it's horizontal. But it's not. It's add 2 to all of the x-coordinates. You want to subtract negative 2, which is the same as adding 2. This x-coordinate used to be 0. 0 plus 2 is 2. This x-coordinate used to be 1. 1 plus 2 is 3. This x-coordinate used to be 2. 2 plus 2 is 4. Goes over to here. This x-coordinate used to be negative 1. Negative 1 plus 2 goes over to here. And this x-coordinate used to be negative 2. Negative 2 plus 2 brings it over to 0. In essence, I've shifted my graph to the right, which is how your book describes it. But I've done so by adding 2 to each of the x-coordinates. So what that gives me is kind of an intermediate step. This is not my final answer, which is why it's the dotted line, is this. But I'm not done. I still have to apply this other transformation. Note that the order is important. If you apply these in different orders, you'll get different final answers. This 2, we're dealing with x-coordinates because these are horizontal transformations. You might think that you multiply all the old x-coordinates by 2, but you don't. You divide by 2. Because I said so. Because I said so up here. Because everything horizontal is backwards. I think you should multiply, you should really divide. I know that's a very sad explanation. This x-coordinate is 0, right? It started out over here, moved right to when I added 2 to it. Now it's at 0. 0 divided by 2 is just 0, so it stays right there. This x-coordinate is 1. 1 divided by 2 is 1/2. This x-coordinate is 2. 2 divided by 2 is 1. This is 3. 3 divided by 2 is 1/2. And finally, this x-coordinate is 4. 4 divided by 2 is 2. What I get for my final answer is just my best attempt to connect all those dots to get something that looks more or less like that. I really like this multiply, divide, add, subtract method better. I find that most people that do it the other way, when they try to compress this graph, they compress it relative to the vertex. So they kind of have something that looks a lot like this dotted line that I have here, but skinnier. You don't compress it relative to the vertex, you compress it relative to the axis, which can really mess people up. So if you just do the multiplication and division thing like I've shown, it eliminates that confusion. But again, if you had a solid grasp on this, fine, do it your way, totally fine. I just want to give you another way in case this was really driving you crazy. This one's kind of crazy because we have 3 different transformations. This negative 2 is a vertical transformation, and this negative 1 is a vertical transformation because they're affecting the f of x. But this plus 3 is a horizontal transformation because it's happening to the x. It's inside the parentheses. And then we got to figure out what type. When we're adding or subtracting a number from the x, it's our first horizontal type. And when we're adding or subtracting a number from the f of x, it's our second vertical type. We have 3 different transformations. I'll start us out with our standard graph of the parabola. And again, I'm starting with f of x equals x squared because of this squared right here. It's the function f of x equals x squared that I'm doing all these transformations to. And I'm going to start with the same 5 points. You don't have to do this many points. I think it's a little overkill. Probably wouldn't argue. Probably is a little overkill. There's a horrible picture of it. Let me try that again. There you go. Got these 5 points. I'm going to transform these 5 points by applying the rules that I keep describing. And I'll connect the dots as best I can. Call it good. So what do I do first? Should I do the verticals or the horizontals? Makes no difference. Doesn't matter if you take care of the verticals first or the horizontals. Totally up to you. Arbitrarily, I'm going to choose to do the verticals first, but it really makes me with the exact same answer. However, when I'm doing the verticals, I have 2 different verticals, and it's very important that I do this one before I do this one. Multiply before I subtract. So I'm going to multiply all of my old y coordinates by -2. This y coordinate used to be 0. 0 times -2 is 0. It's going to stay right there. This y coordinate used to be +1. +1 times -2 is -2. It's going to go down here. This y coordinate used to be 4. 4 times -2 is -8. Way the hell down here. Similarly on the other side, y was 1. 1 times -2 is -2. Y was 4. 4 times -2 is -8. What I get is an intermediate step is this graph here. So that's just an intermediate step. I've just taken care of this guy. Now I want to take care of this guy. Subtract 1. This y from all the y's because it's vertical. This y coordinate used to be -8. -8 minus 1, -9 goes right here. Make it a little bit bigger so I can follow it. -8 minus 1, -9. -2 minus 1, -3. -2 minus 1, -3. 0 minus 1, -1. I get to this graph. Solid red line. Still not done. I've just taken care of all the verticals. I still have to take care of my horizontals. This x plus 3, it's a horizontal transformation because it's affecting x. Everything's backwards. You think you'd add 3 to the x coordinates, but you don't. You subtract 3 from the x coordinates. This x coordinate is currently at 0. It's x coordinate now. It's currently at 0. Subtract 3 from 0, and you get to -3. Get way the hell over here. This x coordinate used to be at 1. 1 minus 3 is -2. -2 on my graph is right in here. This x coordinate used to be at 2. 2 minus 3 is -1. It's going to end up right there. This x coordinate used to be 1. 1 minus 3. Sorry, this x coordinate used to be -1. -1 minus 3 is -4. Goes right there. And then finally, this x coordinate used to be -2. -2 minus 3 is -5. It's right around here. What I get for my final answer is this guy. Transformations. I think they're pretty hard. Do them however makes sense to you. I think this little chart simplifies things a little bit, makes it easier for me. But if it doesn't work for you, completely ignore that. Think about it the book's way, where you stretch and flip and compress and shift. Second topic. I like the second topic a lot more. Maybe you could tell I don't like this first topic. I think it really confuses people, and I don't know how relevant it is. I don't like it. This one I do like. Combining functions. There's 5 different ways you can combine functions. You can add them together, you can subtract them, you can multiply them, you can divide them. None of those are particularly interesting, but they show up on your quiz, so I want to mention them. The 5th way that is interesting is called composition, function composition. So we'll talk about those more when we get there. But before we get there, I want to show you how to do this. So the basic idea is you'll be given 2 little functions, kind of building block functions, and asked to create a new function by this. And what you have to do is understand what the hell this means. I mean, it's just different symbols, right? You're not used to looking at this and knowing what it means. Really, the most important thing to know on this first question is that when they write f plus g of x, which is how you say that, all that means is f of x plus g of x. You can almost think about it like you're distributing the x through, but it's not quite that because this isn't f times x. It's f of x. It's a function. But really, when you see the plus, just know you're adding the two things together. So they gave you the two things up here. F of x is 2x squared plus 1. And g of x is x over 2 plus x. So f plus g of x is this. You can write that in different forms if you want. You can get a common denominator, add things together. I don't think you have to. I think it's perfectly fine just like that. Just know that this means this. Change f of x, change g of x, you're good. If they asked you f plus g of 2, there's two different options. Option 1 is say, well, I now know what f plus g of x is. F plus g of x, I figured out in part 1 was 2x squared plus 1 plus x over 2 plus x. So if you're going to ask me what's f plus g of 1, it's saying I have this function, this machine that's defined by this rule, and instead of putting x into it, I'm going to put 1 into it. Place all the x's with 1s. 2 times 1 squared plus 1 plus 1 over 2 plus 1. So what's that? 2 plus 1 is 3. Plus 1/3. So that's 9/3 plus 1/3. I get 10/3. That's one way you could do that. Another way you could do that is kind of like we did up here when I said f plus g of x is f of x plus g of x. Second option. We could say, well, therefore, it would make sense that f plus g of 2 is just f of 2 plus g of 2. I can figure out f of 2. F of x is this thing. Good. I was afraid I messed something up. F of x is this thing, so f of 2 just says change all the x's into 2's. 2 squared is 4 times 2. I did screw something up. Yep. This was supposed to be f plus g of 2. I figured out f plus g of 1. So I better go back and fix that, huh? So everything I wrote was correct. I just didn't answer the question. It's asking me f plus g of 2. And I answered f plus g of 1. Getting a little bit lazy there, sorry. F plus g of 2. Okay, I have this rule for f plus g of x. Change all the x's into 2's. What do you get here? 2 squared is 4 times 2 is 8 plus 1 is 9. 2 over 4 is the same as 1/2. So this is 18 halves. No, it's not. Yeah, it is. 18 halves plus 1/2, which is 19 halves. That was better. Now I can show you a second way to do it, which in fact isn't all that different from the first way. But the second way you can do it is kind of taking advantage of what we did up here. F plus g of x is f of x plus g of x. Therefore, f plus g of 2 should be f of 2 plus g of 2. In fact, it is. I can figure out f of 2. F of 2 is just look at this mess and change all the x's into 2's. If this were a 2 here, 2 squared is 4 times 2 is 8 plus 1 is 9. G of 2, change all the x's into 2's here. 2 over 2 plus 2 is 2 over 4, which is 1/2. It's 9 plus 1/2. That same answer, and really, maybe you can see that I did the exact same thing, really. In one of them, I relied on this answer I got here. In the other one, I kind of got them both from up here. Do it either way, you'll get the same answer. Probably spent too much time on that because it's not that interesting. F minus g of x, same idea. Really, all you need to know is that this notation, when someone writes something like that, what it means is f of x minus g of x. So since I know what f of x is, it's this 2x squared plus 1 thing, and I know what g of x is, it's x over 2 plus x, let's subtract the two of them, get this answer. And you could write that in different forms. You could combine like terms, I guess you get a common denominator and then combine like terms. You don't have to. I think it's fine the way it is. Now that I can get this 2 here. Next one. What's this notation mean? Probably guessed by now. FG, when you write things next to each other in math, that means you're multiplying them together. Really, I'm doing f times g of x. Just like up here, f minus g of x is f of x minus g of x. F g of x is f of x times g of x. How do we figure that out? Well, I know f of x is 2x squared plus 1. And I know g of x is x over 2 plus x. So sure, I can multiply those together. Could leave it like this, although this one you can kind of simplify it pretty easily. You can multiply straight across and get 2x cubed plus x over x plus 2. Could have left the top factored also if you wanted. Lots of different ways you can write this thing. I'll call that good. Realistically, if you left it like this, I'd give you full credit. I'd say it's fine. Instead of 2 plus x, I wrote x plus 2. Standard when you're writing polynomials is you write them in decreasing order, but as you can see, I don't always do that, so it doesn't really matter which way you write it. Call this good. Finally, f divided by g of x, you probably have a pretty good guess. Just like f times g of x means f of x times g of x, f divided by g of x probably means f of x divided by g of x. Sure does. F of x is 2x squared plus 1. G of x is x divided by 2 plus x. I would not leave this like this. I don't like leaving fractions inside fractions. I think it's complicated. Think of the top as 2x squared plus 1 divided by 1. And then remember that when you're dividing a fraction by another fraction, it's like multiplying them, but you flip 2 plus x. You flip the denominator upside down. Instead of x over 2 plus x, it's 2 plus x over x. So you could just FOIL if you wanted to, or you could leave this as 2x squared plus 1 times x plus 2, or 2 plus x, all divided by x. A lot of forms would be acceptable for this answer. This would be one of the many acceptable answers. This one wouldn't be because you don't want to leave fractions inside fractions, but realistically, if you left it right here, I'd be pretty happy. I don't know what the quiz will allow you to leave in terms of simplification. F divided by g of 2. Much like up here, we have two different options. You can either figure out f of 2 and divide that by g of 2, or you can just say, wait a minute, I know what f of g of x, f divided by g of x is. Figure that out above. So if I wanted f divided by g of 2, just have to take this thing and everywhere I see the letter x, replace it with the number 2. Let's see here. This was 4 times 2 is 8, 9. 2 plus 2 is 4. Divided by 2. Ends up being 18. Divided by g of 2 is 18. I consider this page uninteresting. I mean, I wanted to teach it to you because it shows up on the quiz, but I don't really think it's all that useful. But I just wanted to show it to you. What I do think is useful is the last topic, which will definitely be on the quiz. It's the fifth way you can put these functions together, and it's called function composition. So you often see it written with a little O in here. It's not quite an O. It's kind of in the middle of the line, an open circle. The way you say this is f of g of x. What I do is every time I see this, just like every time I see this, for example. This is messy. It's hard to tell what this means. I rewrite it like this. Every time I see this, I don't like that. I like this. I rewrite it. So when I rewrite it, then I can solve it. Do the same thing with function composition. You might be wondering how you rewrite this. The way you rewrite this is like this. F of g of x, you can write it like this with parentheses. And this is really helpful because when you have it written in this form, what you need to know about function composition, which is what this is called, is you always want to work from inside out. So what I mean by that is I know what g of x is. I know what g of x is. It's given to me in the problem. It says that g of x is x divided by 2 plus x. So instead of writing g g of x on the inside here in the parentheses, I can write x divided by 2 plus x. Then what the question is asking me to find is what is f of this thing? Well, I know f of x is 2x squared plus 1. So f of 2, replace all the x's with 2's, for example. But I don't want f of 2. I want f of this mess. All you got to do is replace all the x's with this mess. 2 times, instead of x squared, I want x over 2 plus x squared plus 1. Should I simplify this? You can if you want. If you want to simplify it, you could. I think it's fine the way it's written. If you wanted to simplify it, you'd say this is x squared, and on the bottom you'd have 2 plus x squared, or you could FOIL that out. Multiply by 2, but I'm just going to do it. By the time I got done explaining how to do it, I could have just done it. Squared, it's the top and the bottom. Now if I multiply across, I get 2x squared divided by 2 plus x squared plus 1. And you can take it even further if you wanted to. You can find a common denominator. Say this is 2x squared over 2 plus x squared. Actually, let me FOIL that out. 2 plus x squared is x squared plus 4x plus 4. And then instead of thinking about this as 1, it's really 1 divided by 1, which I could write as x squared plus 4x plus 4 divided by x squared plus 4x plus 4. This is all just 1. But now I have a common denominator, so I can add up the numerators and get 3x squared plus 4x plus 4 divided by x squared plus 4x plus 4. Realistically, this probably would have been fine, but just showing off some algebra. Here's another answer. That's function composition. So what can they ask you? Things like f of g of 2. There's 2 different ways to figure this out. You could f of g of 2. You could say, well, I can figure out g of 2 because g of x is x over 2 plus x. So g of 2, I'm changing all these x's into 2's. So g of 2 will be 2/4, which is 1/2. So really what I'm trying to figure out is f of 1/2. I can figure out f of 1/2 is just look at f of x, which is 2x squared plus 1. And everywhere you see an x, place it with a 1/2. That ends up being 3/2 if you simplify that. This is a quarter times 2 is 2/4, which is a half. A half plus 2 more halves is 3/2. Here's one option. Option 1. Sorry, this is kind of running into itself. Switch colors. Option 2 is for you to say, wait, I want f of g of 2. F of g of 2. I know f of g of x, I just figured that out over here. So f of g of 2, I'm just changing all the x's in this problem into 2's. Say it's 3 times 2 squared plus 4 times 2 plus 4 divided by 2 squared plus 4 times 2 plus 4. This is 4 times 3 is 12 plus 8 is 20. 24. And on the bottom, I got 4, 2 squared, plus 8, which gives me 12, plus 4, which is 16. 24 16ths. If you reduce that, 8 goes into both of those, and you get 3/2. So either way, you get the same answer. 2 different ways to do it. The next problem, what I wanted to illustrate is that unlike with addition, f plus g of x is not this. F plus g of x is the same as g plus f of x. It's commutative. However, with function composition, it's not commutative. Where am I? I already figured out f of g of x, it was this thing. G of f of x is not necessarily the same. So the way we'd figure this guy out is we'd be like, first rewrite it. Rewrite it into a form that's easier to deal with. Instead of g of f of x, write g parentheses f of x. And work from the inside out. I know that f of x is 2x squared plus 1. I know that's true. That's given to me in the problem. So what I want is g of this thing right here. This is going to work. This will work. 2x squared plus 1. X over 2 plus x. So g of x is x over 2 plus x. But if I replace all the x's in x over 2 plus x with this thing, I get 2x squared plus 1 divided by 2 plus this thing, 2x squared plus 1. And so what I get is 2x squared plus 1 divided by 2x squared plus 3. And what I want you to notice is that this is not the same as this. They're different. G of f of x is not the same as f of g of x. Composition is not commutative. What else can you do with composition? G of x. Why not? If I can do g of f of x, I can do g of x. It's a little bit strange putting a function into itself, but that'll work. First, rewrite it, and start with the inside. I know that g of x here on the inside is x over 2 plus x. So what I need to do is figure out g for this g of x over 2 plus x. So what I do is I look at my function g of x, and everywhere I see an x, I replace it with what's inside these parentheses. So instead of the x in the numerator, I get x over 2 plus x. And I have 2 plus, and then instead of the x in the denominator, I get x over 2 plus x. G of x is this mess. Wouldn't leave it like this because it's not simplified when you have fractions inside fractions. This is a complex rational expression that you saw earlier in this class. If you're wondering why you dealt with these fractions inside fractions earlier in the class, because eventually I knew this problem would come up. So what we want to do is make it one fraction divided by one fraction. In the numerator, I already have one fraction. It's awesome. In the denominator, I don't. If you think about this as 2 over 1, actually, I don't want to write it over there because I think that'll be confusing. Rewrite this here as 2 plus x over 2 plus x. So I've just copied it exactly. If you think about this 2 as 2 over 1, then what you can do is multiply the numerator and the denominator of this fraction by 2 plus x. And the reason you do that is now I have a common denominator down here, 2 plus x and 2 plus x. So in the numerator, I got x over 2 plus x. In the denominator, I got 4 plus 2x. That comes from this 2 distributed into this 2 plus x, divided by 2 plus x. But then I also have x divided by 2 plus x. When I have a common denominator, I can just add up the numerators and get here. So really what I have is x over 2 plus x divided by 2x plus x is 3x plus 4 over 2 plus x. And now the way you divide fractions is kind of like multiplying them, except you multiply by the reciprocal of the denominator. Flip the bottom upside down. You get here. Note that this 2 plus x and this 2 plus x cancel out, and so what I'm left with is x over 3x plus 4. Pretty tricky algebra going on in here. G of x. Finding the domain of composite functions is a good question because everybody gets it wrong. You're like, wait, I just found g of x. This is g of x over here, right? G of x is this thing. So to find the domain, I can't take the square root of a negative number. That's fine. There's no negatives going on here, square roots. But I also can't divide by 0. So to find the domain, I got to make sure that 3x plus 4 does not equal 0. In other words, I got to make sure that 3x is not negative 4. In other words, x is not negative 4/3. That's not all. Most people get that right and think that they're done, but you're not done. Anytime you want to find the domain of a composite function, anytime, you have to look at two things. You have to look at your composite function over here, but you also have to look at the domain of the inside function. So the inside function here is g of x. In this specific case, it was g of x that was on the inside of the parentheses. So I have to not only make sure that I don't break the machine in this step, I have to make sure that I don't break the machine in this step. I not only have to consider the domain of this thing, I also have to consider the domain of g of x. If you look at g of x, way the hell up here when I told you g of x, I'd have to make sure that 2 plus x is not 0 also. So what I'm saying is to answer this question, there's two different things we got to do. Got to make sure 3x plus 4 is in 0, but we also have to make sure that 2 plus x is in 0. To make sure that x is not negative 2. So the domain of this function is all numbers except for negative 4/3 and negative 2. Solve these numbers, solve these numbers, solve these numbers. It's just not this one, and it's not this one. It's everything from negative infinity all the way up to negative 2. Union everything from negative 2 up to negative 4/3. Union everything from negative 4/3 up to infinity. Everything except for these 2 points. Domain of a composite function. Just be careful. You can't just look at this. You got to look at your final composite function and your inner function, the one on the inside, only the one on the inside. Last thing I want to mention on composite functions is you can compose 3 different functions together if you want. 4, 5, you can do as many as you want. So I can find g of f of x. The way I do that, start by rewriting it and work from the inside out. Get the right amount of parentheses there. Nope. Work from the inside out. I know that f of x, the inside f of x, is 2x squared plus 1. So instead of writing f of x here, I'll write 2x squared plus 1. And now what I can do is take the next layer off. I want f of 2x squared plus 1. So f of this thing is, look at your function f of x, and everywhere you see an x, replace it with 2x squared plus 1. So 2x squared plus 1 squared plus 1. 2x squared plus 1, except instead of writing x, I wrote what was in the parentheses. Still not done, because I want g of this huge mess. G of this huge mess is, look at your function g of x, which is x over 2 plus x. And everywhere you see the letter x, replace it with all this mess in the parentheses. 2 over 2x squared plus 1 squared plus 1 divided by that same thing, 2x squared plus 1 squared plus 1 plus 2. I guess in my function I have 2 plus x, so let me write this in a different order. I want to make it line up with my function. My function g of x is x over 2 plus x. So everywhere I see an x, replace it with all this stuff. So here's the top, here's the 2, and then this x right here, I'm going to put everything from here. What I'm saying is, get that to go away. Plus the input to this function, which is all this mess. This is a little bit messy. Could you leave it like this? Yeah, probably. Or you could FOIL things out if you wanted to. I don't know. I'd be fine with you leaving it 2x squared plus 1 squared plus 1. Maybe this 2 and this 1 we should put together and call it 2x squared plus 1 squared plus 3. If you really wanted to FOIL these out, you could. I'd be fine with it just like this. The point that I wanted to make here was less about the simplification and more about what to do when you're composing 3 functions together, because that happens on the quiz and on the homework. Composing 3 functions work from the inside out. Just repeat this process iteratively. All right. Quiz 10 is over, kind of. For me, it's over. Quiz 11. Quiz 11 is kind of a tricky one because I teach it very differently than what you guys have to do. Quadratic min and max. So the basic idea is when you have this function, you don't know what the graph looks like. There's 2 different ways to find out what the graph looks like. The first way is to write it into vertex form, the standard form, and then view it as a bunch of transformations. Use what you learned in quiz 10 to come up with the answer. That's the hard way. Hard way. I'm going to show you how to do it because I feel guilty if you never saw this, but I don't think you'll ever have to do this on your quiz. The hard way is to complete the square to get this into standard form. So I like to think about it as, well, I'll just show you. 2x squared minus 5x minus 3. If I want to complete the square, I need all my x squared and my x terms together, so I add 3 to both sides of the equation. And then if I want to complete the square, I need the leading coefficient to be a 1. So I'll divide both sides by 2. now I can complete the square. The way I can complete the square from here is I need to add something to both sides of the equation so that I end up with the perfect square on this side. That something will always be half of this number squared. So half of 5 halves is 5 fourths. 5 fourths squared is 25 sixteenths. You're going to add to one side, you got to add to the other side. The reason I did that is now on the right-hand side of the equation I have a perfect square. It's always going to be x plus this b divided by 2. Negative 5 halves divided by 2 is negative 5 fourths. This entire thing is this. Get you here. Now if you solve for y, what you get is the standard form of this parabola. Like I said, this is the hard way. There's a way around it. You don't have to do things this way. I'm going to finish it up. I'm going to solve this thing for y. I'm going to subtract 25 sixteenths from both sides of the equation. I want to get y by itself, so I better get rid of this 2, multiply both sides of the equation by 2. Note that I have 2 terms on the right-hand side, so they both have to get multiplied by 2. So I put a 2 out here, and I multiply this by 2. 25 sixteenths times 2 is 25 eighths. And then subtract 3. Get y equals 2 times x minus 5 fourths squared minus 25 eighths minus 3. Simplify that a little bit if you want. 3 is the same as 24 eighths. So negative 25 eighths minus 24 eighths is negative 49 eighths. The hard way to do this is to get this into this vertex form. Once you get it into this vertex form, you can answer all of these questions. There's a way to answer these questions without getting it into vertex form. What they ask you on your quiz is to either they'll start you out with this form right here, so they won't make you do all this, and ask you to interpret your answer to answer all the future questions, or they'll start you out like this, and you can use a shortcut. And so I'll show you how to use the shortcut. If we were to find the vertex, if we had it in this form, you'd have to view this as transformations. This is a vertical transformation where I multiply all the y coordinates by 2. This I subtract 49 eighths from all the y coordinates, and this I add 5 fourths to all the x coordinates. The vertex on f of x equals x squared starts out at 0, 0. And so when I take the height of 0 and multiply by 2, it's still 0. But then when I subtract 49 eighths, the height becomes negative 49 eighths. What I'm trying to say is the y coordinate of the vertex will be negative 49 eighths. The x coordinate of the vertex started at 0, and I added 5 fourths to all the x coordinates. So it's 5 fourths, negative 45 eighths. Shortcut, it's always the opposite of this number. So this was negative 5 fourths, I put it in positive 5 fourths, and then this number here. This makes no difference when you're trying to find the vertex. This is the vertex. The hard way to get the vertex, going through all those steps. Easy way is that the x coordinate of the vertex is always negative b divided by 2a. Little shortcut. What I mean is if you think about this is a, this is b, and this is c, negative of negative 5 divided by 2 times a gives me 5 fourths. Note that 5 fourths is the x coordinate of the vertex. You don't have to go through all these steps because the x coordinate of the vertex is always negative b over 2a. Wait, but that doesn't tell me the y coordinate of the vertex. Right, but if you have the x coordinate of the vertex, you can find the y coordinate by taking that point and plugging it in. So the y coordinate is f of 5 fourths. It's take this equation f of x, and everywhere you see an f, everywhere you see an x, change it into 5 fourths. If we evaluate this thing, this is 25 sixteenths times 2, which is 50 sixteenths. This is 5 over 1 times 5 over 4. It's 25 fourths. And this is 3 over 1 if you want. could say this is 25/8. To get a common denominator, I'd have to call, whoops. It's gonna work. Yeah, I think it's gonna work. This would be 50/8, and this is 24. And so 25 minus 50 is negative 25, minus 24 more is negative 49/8. And so note that the x-coordinate of the vertex and the y-coordinate of the vertex are the same things we found here. I think this way is easier than this way. I force my students in the in-person class to do it this way. Since you guys aren't learning from my lecture, that you're learning from the book. The book doesn't force you to do it this way, fine. Do it however you want. Just be able to get this answer. Does the graph open up or open down? The way to think about that is our standard parabola, f of x equals x squared, looks like, well, I got them all over the place. Looks like this thing in blue here. This opens up. However, when I had a negative out in front of the whole thing, that flipped it upside down and made it open down. The way I'm going to end up with a negative out in front is if my leading coefficient is negative. So if the a here is a negative number, it's going to open down. If, it's hard to write for me today, apparently. If a is less than 0, it's going to open down. If a is greater than 0, it's going to open up. A will never be equal to 0 because you're going to be given a quadratic function. So in this case, a was 2, so it opens up. What is the equation of the axis of symmetry? Kind of a dumb question. Understanding what the question is asking is really the hardest part of it. And really all it wants to say is, again, our standard parabola here, there we go, this guy is symmetric. Right now it's symmetric over this line, which is x equals 0. But I don't have a standard parabola. I have a standard parabola that was shifted all around. Whereas, here it is, shifted and stretched and did all sorts of weird stuff to it. So where's the new axis of symmetry? Well, the answer is the axis of symmetry is always a vertical line, so it's x equals something. And it's just x equals the x-coordinate of the vertex. The x-coordinate of the vertex was 5/4. So the answer of the x equals 5/4 is my axis of symmetry. Always x equals the x-coordinate of the vertex will give you your axis of symmetry. Y-intercept. The y-intercept happens when x equals 0. So take your equation. You can use this form of it, but it's easier to use this form of it and change all the x's into zeros. Change all the x's into zeros. You get 0 minus 0 minus 3. Get negative 3. Find any x-intercepts. X-intercepts happen when f of x equals 0. So to figure that out, we take our 2x squared minus 5x minus 3. Set that equal to 0 and solve. 3 different ways you can solve this. You can complete the square, you can use the quadratic equation, or you can factor. I prefer factoring. When the leading coefficient is not a 1, the way I factor it is a 3-step process. The first step is to find two numbers that multiply to negative 6, a times c, and add to negative 5. Two numbers that multiply to negative 6 and add to negative 5 are negative 6 and positive 1. So what I'm going to do is replace, instead of negative 5x, I'm going to write negative 6x plus 1x. I'm going to replace the negative 5x with the answers to the question, what two numbers multiply to negative 6 and add to negative 5. Now that I have 4 terms, I'm going to factor by grouping. This first group, these first two, their greatest common factor is 2x. If I pull out a 2x, I'm left with x minus 3. Pull out a 2x, I'm left with these guys. I have to pull out something from these guys to be left with an x minus 3. I already have an x minus 3 here, so just pull out a positive 1 as kind of a placeholder. Now I have two terms that both have an x minus 3 in them. So I factor out that x minus 3, and I get here. What I now have is something times something equals 0, which is true only if the first thing equals 0 or the second thing equals 0. Solve these two equations, I get my two x-intercepts. sketch a graph of the function. The information that I found, I can do it. I know that the vertex was at 5/4 and negative 49/8. So 5/4 is a little bit more than 1. Negative 49/8. Well, let's see, negative 48/8 would be negative 6. So I'm a little bit further down than there, and a little bit to the right of 1, somewhere in here. This point right here is 5/4 negative 49/8. And then I also knew that the x-intercepts were at 3 and negative 1/2. There's 3. There's negative 1/2. And I knew that the y-intercept was at negative 3. 1, 2, 3. And I knew the parabola opened up, but yeah, I mean, it would have to open up if it's going through these 2 points. Connect the dots as best you can. You got the graph. I would say make sure you label these points because those are the answers we found earlier. All that good? State the domain and range. All right, so kind of a trick question, kind of a dumb question. The domain is always negative infinity to infinity. The domain of a parabola, actually of any polynomial, is always negative infinity to infinity. All you have to worry about with domain is that you don't divide by 0 and you don't take the square root of a negative number. There are no square roots in this problem, and there's no division with the variable in the denominator. Nothing can go wrong. All real numbers are in our domain. We're going to write that in interval notation. We write it like this. Range is a little bit more interesting. Range is all the possible heights. You get that by looking at this picture. This graph goes up as far as I want it to go, so it's going to go all the way up to infinity, but it doesn't go all the way down to negative infinity. It stops here at negative 49/8. So the range is everything from negative 49/8 up to infinity. Note that this point is in the range of the graph. I can get negative 49/8 out of this machine, just put 5/4 in. Before I want to include this point, so I have to put brackets here. The standard is always to put parentheses on infinities. The brackets on negative 49/8 is important. All right, we're almost done. Really the main topic for quiz 11 is this idea of quadratic min and max. So this seems like a lot in this first thing, but it's really everything you're doing, or the vast majority of it on quiz 11. If you run across a few word problems, they'll seem completely unrelated. It'll turn out they're not. Turn out all the word problems really are just quadratic functions like this guy hidden in a word problem. What you have to do is come up with this quadratic function and then figure out, are they asking me for the vertex, the x-coordinate of the vertex, the y-coordinate of the vertex, an x-intercept? Like based on the wording, you got to figure out what they're asking for. So for example, in this first one, the height of a football after I throw it is given by this equation. So what I'm saying is there's some person, and there's me, standing over here, and I throw a football, and it goes up, and then it comes back down. And if you kind of traced out this dotted line and you continued it over here into negative land, what you get is this shape of a parabola. And so what they're saying is the height can be modeled by this equation. In other words, this dotted line right here is negative 2t squared plus 7t plus 4. Why t's instead of x's? Because I'm talking about time. But we'll just put the t's on this axis. And so really what you got to do is you got to read the question and figure out what they're asking for. What part of this question are they referencing in this word problem? Find the maximum height attained by the ball. So the ball is as high as possible right here. Yeah, I mean, it's only this high over here, and it's only this high over here. Right here, it's as high as possible. It wants to know what this height is right here. This is the maximum height attained by the ball. Instead of thinking about it as the maximum height attained by the ball, it's also the y-coordinate of the vertex. The vertex, because I'm talking about this point right here, and the y-coordinate because I want the height. Just want to find the y-coordinate of the vertex for this parabola. Well, the x-coordinate of the vertex, maybe I'll say the maximum height equals the y-coordinate of the vertex. It's hard to figure out the y-coordinate of the vertex, but I can figure out the x-coordinate of the vertex. vertex. Two different ways. Easy way or the hard way. The hard way where you say y equals, subtract 4, divide by -2, complete the square, solve for y, and you get it into the standard form. Or the shortcut where you do negative b over 2a. And you say, well, b is 7, and a is 2. A is -2. So negative b over 2a is just 7/4. So the x-coordinate of the vertex is 7/4. Unfortunately, that's not what they're asking for. They're asking for the y-coordinate of the vertex. However, I can find the y-coordinate of the vertex by figuring out f of 7/4. F of t is -2t squared plus 7t plus 4. So f of 7/4 is -2 times 7/4 squared plus 7 times 7/4 plus 4. Which, if you're good with fractions, -2 over 1 times 49 over 16 plus 7 over 1 times 7 over 4 plus 4 over 1. See, this 2 and this 16 cancel, and I get -49/8. Over here, I got 49/4. And over here, I got 4 over 1. Kind of running low on room. I wanted a common denominator. My least common denominator is 8. So I multiply this by 2 over 2 and get 98 over 8. And this would be 32 over 8. And now that I have a common denominator, I can just add the numerators. -49 plus 98 is 49. 49 plus 32, 81. Is that right? 49 plus 32 is 81. Yeah, that's right. 81/8 is the y-coordinate of the vertex. I don't know what the hell the units are here. The maximum height attained by this football that I'm throwing is 81/8. So a little bit more than 10 meters, maybe. I don't know. I just don't have a very good arm. I don't care about units. Find the maximum height attained by the ball. It's this thing right here. I wanted to contrast that to the second question. How long does it take for the ball to hit the ground? So what they're saying is the ball hits the ground way out here. It wants to know what is t at this point right here. In other words, it wants to know what is the larger of the two x-intercepts. How do I figure that out? This point right here, if you think about this dotted line as our graph, is an x-intercept. There's also one over here that doesn't really make sense in the context of the problem because it would be -t, where the ball is before I throw, which doesn't really make sense. So there's two x-intercepts, or t-intercepts if you want. And the larger of the two, this guy out here, is the x-coordinate will tell you when the ball hits the ground, when the height is equal to 0. So all you got to do is take the equation, the -2t squared plus 7t plus 4, and to find x-intercepts, set that equal to 0, and solve. Again, 3 different ways to solve it. Complete the square, quadratic equation, or factor. You're going to factor, since the leading coefficient is not a 1, you need to find two numbers that multiply to -8 and add to +7. Let's see, the two numbers in this case are 8 and -1. And so what you do is you replace 7t with +8t and -1t. Now you have 4 terms, so what you can do is factor by grouping. This first group, the greatest common factor, either 2t or -2t. I'm going to do -2t. Although you can do it either way. Pull out a -2t, you're left with t minus 4. You want to be left with t minus 4 over here. Better pull out a -1. When I now have our two terms that both have a t minus 4 in them, so factor out that t minus 4. This is gone. This is gone. All you got left is -2t minus 1. Trying to figure out when this thing equals 0, but this thing is the same as this thing. This thing equals 0 when either t minus 4 equals 0 or -2t minus 1 equals 0. So either a t equals 4 or when -2t equals 1. In other words, -1/2. Two different answers. Weird. Oh, right. There were supposed to be two different x-intercepts. one out here and one out here. The negative one doesn't make sense in the context of this problem. It's the positive one we want. So our answer is 4. After 4 seconds, the ball hits the ground. Again, I don't have a great arm, I guess. So really the point of this problem that I wanted to make is it's a word problem. It feels totally different than anything you did in the previous problem. But really it's the same thing. Find the y-coordinate of the vertex, find the x-intercepts. It's just being able to read the problem and figure out what they're asking you for when they say things like find the maximum height or how long does it take for the ball to hit the ground. Last problem of this review session went a little bit long. I try to keep these to an hour usually. We're an hour and 4 minutes right now. I want to fence a rectangular yard in front of my house. I'll only need to fence 3 sides of the rectangle. I kind of drew a little picture here because I have a big house right here and it's going to be one side of it. Okay? And I have 600 meters of fencing. What are the dimensions of the largest yard I can make? All right, so the area of a rectangle is length times width. Unfortunately, that won't help us because we can't have 2 different variables. We only deal with 1 variable function in this class. However, we have a total of 600 meters of fencing. And if you think about this rectangle right here, I'm going to have to build a fence here, here, and here. I'm going to have 2 W's and 1 L. 2W and 1 L better be 600. Right? I want to use up all the fencing I have. And since I don't fence this side, 2W plus L equals 600. Why this is relevant is I have an equation relating together L's and W's. So what I can do is I can solve this equation for one of those 2 variables. Which one makes no difference? Maybe L equals 600 minus 2W if you want. Makes no difference which one you solve for. Solve for one of them. And then substitute that up here. Instead of L, I can write 600 minus 2W times W. Still don't see what's going on. All right, let me take it one step further. Instead of area being length times width, I can think about it as this times width. And if I take that W and distribute it through, I get negative 2W squared plus 600W. In other words, the area is a function of just 1 variable, W, and it's given by this formula right here. Note that this is a quadratic formula. I want to find the largest area possible. I want the area, the f of x, or f of W in this case, to be as large as possible. I want to know what is the y, where's the vertex, basically. What this is saying is that the area, I don't know if you need this graph, but I'm going to do it. So if I graph negative 2W squared plus 600W, this is my W axis, this is my A axis. What's going on is I can change the width. I can have the width be 0 and have everything be length, but then I don't get any area. And then I can make the width larger and larger and larger, and there's some sweet spot in here where the area gets as large as possible. But then when I start making the width too large, I'll make it all the way out here. If I make it 300, then I'll have nothing left for length, so I'll get an area of 0 again. So it's like anywhere from here to here makes sense. But there's one sweet spot up here that I'm looking for, the vertex. Really, it's just saying find the vertex of this function. 2 different ways to do it, the hard way and the easy way. The easy way is that the x-coordinate of the vertex is always negative b over 2a. Negative 600 over negative 4 is 150. So what that is saying is that if I want things to be optimal, the x-coordinate or the w-coordinate of the vertex is 150. This optimal area right here, W, is equal to 150. I can figure out what length is equal to. No, that's not true. I can figure out what the area is by taking this 150 and plugging it back into the original equation. But I'm not interested in what the area is. I don't care what this is. I wrote that backwards. The W is the x-coordinate here. So it's actually 150 and then comma something. I don't care what the y-coordinate is. I just care what the x-coordinate is. So what I'm trying to get at here is that the optimal width is 150. What the question is asking me for is what are the dimensions of the largest yard. So I couldn't just stop and say W is 150. I have to take it one further and be like, well, let's see, if W is 150, and length is 600 minus 2 of these 150s. Length is 600 minus 2 of these 150s, which is 300. So the optimal yard, I'll have my W be 150 and my length be 300. But the point that I wanted to make is really these word problems are these quadratic equations in disguise. It's the same basic idea, except what you need to do is realize what they're asking for. And in this case, they're asking for the x-coordinate of the vertex. The x-coordinate of the vertex will be the optimal width. So I guess that's it. That's all I got on this one. Hopefully that helps people out a little bit on this quiz.